Okay, we'll get started with section 8.4 now. In 8.4, we're going to talk about quadratic equations and rational equations, but before we do that, we want to do a review of factoring. Now, factoring is super important in algebra. One of those things that you got to constantly practice. It will not go away, right? Like anything else, the more you practice, the better you get. So I would encourage you to practice factoring. That can really be a topic that could pull away a student away from algebra if they have troubles with factoring. So it's a good idea to review and practice this, like I said. Problem 18 is just a bunch of factoring review problems. So we're going to factor completely if the expression cannot be factored, write prime. Now, the first thing that we want to do when it comes to factoring is we want to determine if there's a common factor in the terms. In part A, there is a common factor. In other words, 7 will go into 35 and 14 evenly, and x squared will go into x cubed and x squared evenly. So 7x squared would be in common to these two terms. Let's go ahead and factor that out. The leftover then would be 5x from the first term. 7x squared times 5x would be 35x squared. And then 7x squared times negative 2 would be a minus 14x squared. So 5x minus 2 would be the leftover. Okay. Part B, we want to factor x squared plus 10x plus 16. Now there is no common factor in these three terms. So for this problem, when we say factoring, we're going to create two binomials. Now, binomial is just an expression that has two terms on it, okay? We want to factor and check our answer by foiling back, okay? So FOIL is first, outer, inner, last, and students in beginning algebra do lots and lots of factoring and foiling. And, the nice thing about factoring is that we can always check our answer by foiling back, if it's a trinomial that did factor. Okay, a trinomial is where we have three terms. I've got a trinomial here. So I know x times x is x squared. That's the first terms. And everything's positive here with the signs, right? So I got plus and plus. And I have to think of two numbers such that I multiply to get 16 and I add to get 10x. Okay, well, I know 2 times 8 is 16. Also, if I take 8x plus 2x, I get 10x in the middle. Okay, so first terms, the outer terms, the inner terms, and the last terms, foiling, gets me back to where I started. So x plus 2 times x plus 8 would be correct. Okay, now over here, I don't have just x squared, but it's a 2x squared. The factors of 2 are 1 and 2. And by the way, when it comes to factoring, like there's an element of guessing and checking that goes with that, but we like it when we have a 1 in front of x squared, since there's less guessing and checking then, okay? In this case, so the factors of 2 are 1 and 2. Now 20 has lots of factors, right? There's 1 times 20, 2 times 10, 5 times 4, right? And so I'm going to be guessing and checking. Now, that last term is a positive, the middle term is a negative, and so the only way for that to happen is both of the signs are minus signs, okay? Now, negative times negative is positive at the end. Negative plus negative is negative in the middle. And again, I'm going to be checking this by foiling back. If I use 5 and 4, and then I FOIL, 2x times x is 2x squared. The outer and the inner terms, I'm looking at negative 8x minus 5x is negative 13x in the middle. That looks good. And then the last term is negative 5 times negative 4 is 20. That looks good. Okay. Now, of course, if I had tried 10 and 2 or 1 and 20, things didn't work out, I would be moving on to other factors. And so, like I said before, there is an element of guessing and checking to this. Here's another one, 4x squared minus x minus 3. So we like it when we were working with prime numbers. A prime number is a number whose factors are 1 in itself. Okay, like with 3, there's not, the only factors of 3 are 1 and 3. So we like that, it's less guessing and checking. So I'll put the 3 here and the 1 here. That's a minus 3, right? So the signs are going to alternate. It's either going to be plus minus or minus plus. I know positive times negative is negative, or negative times positive is also negative. Now, since I don't have just x squared at the beginning, the signs are going to be something that I would situate at the very end of this arrangement. 4 has factors 1 and 4 or 2 and 2. If we try 4 and 1, then FOIL this back. Okay, 4x times x is 4x squared. And then the outer and the inner terms, we have a 4x and a 3x. Well, if I had negative 4x plus 3x, that would give me negative x in the middle. So I'd want to get the signs positioned now. It's going to go plus minus. 3 times negative 1 is negative 3 at the end. Here's another one. Okay, 6x squared plus 11x minus 10. Now there's going to be more guessing and checking when there's more factors, right? So with 6, it's going to be 1 and 6 or 3 and 2. With 10, it's going to be 1 and 10 or 2 and 5, right? And so I would go through the guessing and checking procedure to have this work out. If we use 3x and 2x for the factors of 6x squared, and then 2 and 5 for the factors of 10. Now it's a minus, right? So that, again, the signs would be something that I would arrange at the very end. It's either going to be minus plus or plus minus there. And okay, if we check this now by foiling, 3x times 2x is 6x squared. The outer and the inner terms, we're looking at 15x minus 4x is 11x in the middle. And then negative 2 times 5 is negative 10 at the end. Here's another one. Now, again, I would reemphasize, when it comes to factoring, always think of a common factor first. Students sometimes don't do that, and then they're making the problem more difficult than what it needs to be. Like with this one here, okay, 42 has lots of factors. But I don't need to be working with 42 since 3 is in common to all 3 of these terms. It's going to be easier if I factor out a 3, and I like that because now I got a 1 in front of x squared, and I'm working with 14 now rather than 42. Okay, it's less guessing and checking. So when I factor what's inside the parentheses here now, I know x times x is x squared. With 14, we're using 7 and 2. And if we take 2x minus 7x, that gives us negative 5x in the middle. That looks good. And then negative 7 times 2 is negative 14 at the end. So yeah, again, don't forget about that first step. If there's a common factor, factor out that number or that term, whatever it is there. Okay. Sometimes we have a negative number in the first term, so it's easier to factor that out. I've done that here in this part. Factor out the negative 1, and the factors of x squared are x and x, right? With 70, it's going to be, again, 70 has lots of factors, right? And we're trying to get 17x in the middle. Or a negative 17x, right? Because I already factored out the negative 1 there. And so I've used 7 and 10. Both the signs are negative signs in order for me to get that positive 70 at the very end there. Negative 10x minus 7x is negative 17x in the middle. And then negative 7 times negative 10 is 70 at the end. Okay, now when it comes to factoring, we've been working with trinomials here mostly for these problems. Here's one that has more than 3 terms. Okay, we call that a polynomial. A polynomial is just something that has 1 or more terms to it. There's special kinds of polynomials though, like a binomial, a trinomial. When it's 4 or more terms, we just simply call it a polynomial. Okay, now when it comes to factoring, if you have something that is 4 or more terms, again, the first thing that you're looking for is if there's a common factor, but if we don't have anything in common to these 4 terms here, so the method that we're going to use for factoring is called factor by grouping. And in this problem, I'm going to let the first 2 terms be one group, and then the last 2 terms be a second group. So what's going to come out of group 1 is x squared. In other words, x squared is in common to these first 2 terms. Let's go ahead and pull that out. The leftover then would be x minus 8. Now to have this work out, I need another x minus 8 coming from group 2. If I can't get that, then this method didn't work and I got to think of something else. So what's going to come out of the last two terms would be a 4, because if I factor out 4, I'm going to be left with x minus 8, right? Distribute that back, 4x minus 32, that's what I see right above there. Now I've got x minus 8 in common to these two groups. Let's go ahead and factor that out of the whole thing. The leftover then from group 1 would be x squared. The leftover from group 2 is a plus 4. And now I'm done factoring. Okay, so factor by grouping, it sometimes comes up in a few of these problems. The idea is to establish groups and have the common factor in each one of those groups there. Okay, here's a couple of definitions. When it comes to factoring, sometimes certain kinds of expressions come up a lot and they're just worth knowing. A binomial expression of the form x squared minus y squared is called the difference of two squares. That comes up quite a bit actually, and it can be factored as x plus y times x minus y. I want the signs to alternate because when I FOIL this back, in the middle I'll have negative xy plus xy, that's 0 in the middle. Okay, y times negative y is minus y squared at the end. A binomial that is the sum of squares, x squared plus y squared, cannot be factored, and we call that prime. Okay, it can't be factored further. A binomial expression of the form x cubed minus y cubed is called the difference of two cubes. And here's how the difference of two cubes factors. I look at the numbers that I'm cubing, which are x and y. And then on this trinomial part, I want to square the first number, square the last number. So there's going to be an x squared at the beginning, a y squared at the end, and then that middle term I'm going to multiply x and y together. Now with the signs, I want to look at the sign, and whatever the sign is, it's going to be same, different, plus. Same, different, plus. Okay, so with the minus sign, I'm going to want that same sign, different sign, plus sign. Same, different, plus. A binomial expression of the form x cubed plus y cubed is called the sum of two cubes, and here's how that factors. Now you'll notice that these formulas here are very similar. The only thing is that you got to get the signs correct. Okay, so we want same, different, plus. Right, here's a plus sign, I want that same sign, and then a different sign, and then a plus sign. There's always a plus sign at the end here with factoring this sum and difference of two cubes. Okay, so let's get some practice factoring here, these types. Factor completely. If the expression cannot be factored, write prime. Okay, in part A, I want to recognize that I've got the difference of two squares. I know that 9 squared is 81, right? So I've got x squared minus 9 squared. I'm subtracting two squares, and that means that I'd want to be using this formula that is the difference of two squares. X plus 9 times x minus 9. I want the signs to alternate. That way when I FOIL this back, that middle term goes to 0. And of course I can check by FOILing. Right? X times x is x squared. Negative 9x plus 9x is 0 in the middle. And then 9 times negative 9 is negative 81 at the end. 9 squared is 81, right? So x squared plus 9 squared, that would be the sum of two squares. The sum of two squares cannot be factored, and so I just write prime. In other words, this is as simplified as we can get it, okay? Like it doesn't factor further. That's what we mean by prime. Here's another one, part C. Okay, so 9x squared minus 100. Again, it's kind of hidden, but I'd want to look at this as the difference of two squares. I know 3 squared is 9. When I square x, I get x squared, right? So when I square 3x, that whole thing, I get 9x squared. 10 squared is 100. So by writing it like this, I can see that I'm subtracting two squared things, okay? And that means that I want to be using the difference of two squares. Well, it's going to be 3x plus 10, 3x minus 10 then. Again, make sure that the signs alternate. Here's the sum of two cubes. Okay, and it's kind of hidden, but that's how I'd want to look at this problem. I know 2 cubed is 8. When I cube x, I get x cubed. 3 cubed is 27. 3 times 3 times 3. Okay, so I've rewritten this in such a way so that I'm adding two cubes together. And that means that I can then use my formula, this guy right here. So in the binomial part, that first part, I just take a look at the two things that I'm cubing, which are 2x and 3. It's going to be a plus sign. I want the same sign, different sign, plus sign. In the trinomial part, this part here, I'm going to square the first term. 2x squared is 4x squared. And then at the end, I'm going to square the last term. 3 squared is 9. And then to get the term in the middle, I multiply 2x and 3 to get 6x. Once you've used the either one of these two formulas, it doesn't factor further. Okay, so right here is, you know, what we see, 2x plus 3 times 4x squared minus 6x plus 9. That would be my answer. Here's another one. Okay, and I've got the difference of two cubes. Okay, now 3 cubed is 27. When I cube x, I get x cubed. 4 cubed is 64. 4 times 4 times 4. And when I cube y, I get y cubed. Okay, so I've rewritten this in such a way so that I'm subtracting two cubed things. And that means that I want to be using this formula here. Okay, so I'm going to be writing the two things that I'm cubing, that is a 3x and a 4y. It's a minus sign, right? I want the same sign, different sign, plus sign to get my signs arranged. In this part here, I want to square 3x to get that first term. 3x squared is 9x squared. And then to get the last term, I square 4y. 4y squared is 16y squared. And then to get the middle term, I multiply 3x and 4y. That'll get me 12xy there in the middle. Here's one more in this group. So I see that I've got more than 3 terms, and I don't have anything in common to these 4 terms here, which means that I want to think the factor by grouping again. Let's let the first 2 terms be one group, and then the last 2 terms be a second group. In common to the first group would be x squared. Okay, and so if we factor that out, we're going to be left with x plus 3 as the leftover. I'll need another x plus 3 coming from group 2. And so if I factor out a negative 4, make sure that's a negative and not a positive, since I need another x plus 3 coming from group 2. X plus 3 is now in common to these 2 groups. You can factor that out of the whole thing, and that's what I've done in the next line. The leftover from the first group is x squared. The leftover from the second group is a minus 4. And now some students might make the mistake and circle this result here. You don't want to do that. We want to factor completely. Okay, factor as far as you can go. Like any other math problem, go as far as you can go. X squared minus 4 is going to factor further. I know 4 is the same as 2 squared, right? And so if I look at it as x squared minus 2 squared, then I've got the difference of 2 squares. Well, that's going to factor nicely, right, as x plus 2 times x minus 2. And so now I'm done, right? X plus 3 times x plus 2 times x minus 2. That would be as simplified as I can get it, and that would be my answer then. Okay, so again, make sure that you're factoring completely. And we'll stop the video here.